All right, good morning. So just a quick announcement about the assignment. So a couple of students have told me that when they try to use nextInt with the random number generator, when they pass in two values, it doesn't work, right? And so you can see here in my Eclipse, it's also complaining there's no version of nextInt that takes in two values, right? And so in the assignment specifically says pass in two values, right? So if you have a piece of Python code that does random, I can't remember the name of the random number generator function in Python, but the Python one takes in two values, and the Java one, so the assignment says when you call nextInt with the Java one, also use two values. So I thought I had the assignment configured so that this would work. But one of the things, so one of the issues, the issue if you're running into the problem where you can't pass in two values, the solution turns out to be very easy. Right? And so the random numbers that you're generating in the assignment, they all are between 0 and some value. Right? So suppose you want max value. I want the maximum value to be 100. Right? So I want to generate values between 0, 1, 2, 3, 4, up to and including 100. Right? If to do this correctly in Java, right, using the 2 parameter version of the method, you would write in max value plus 1. Right, because Java's random number generator does not include the end point, right? That's the end point, right? Now, if this doesn't work for you, because all the numbers that you're generating are between 0 and something, right? You can just delete the 0 and use the 1 argument version, right? And that should work for you, right? And so there is a 2 argument version of the method, but the 2 argument version of the method was added to a very late version of the Java language. So it's entirely possible that I have the assignment configured to use the wrong version of the JDK. But I think it's not. I think the version that I have it configured for, there should be, it should recognize that there's a 2 argument version. Yes, question?
I think in the description of the assignment,
yeah.
you give a way to do it like you.
Do I actually say how to do it with 1 argument and 2?
Because it says whenever a line
yeah.
says like this, then it does the random RNG equals new random. And then
yeah.
you say whenever it says like the 2 numbers,
yeah.
it says to do this. Because I didn't have a problem with it.
Yeah, but I think the way it says it says use 2 values. Yeah, it says use 2. So I have to change that. So I'll edit the assignment later this afternoon and post an announcement to tell you how to deal with the problem if you're running into this problem. Because it's not a problem you can easily fix.
In your description, you did I, J plus 1.
Yeah. 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 So the 2 argument one, so it's working for some people, it's not working for everybody. That's the problem. So, any other questions over here? Okay, yes.
So for the def function, I've translated to public static void. Is that okay to keep?
All of your methods for assignment 1, they're all public, they're all static. If they return a value, then you have to say what the return type is. If the method doesn't return a value, then it's void.
But I did public static void, and boolean is public static boolean. Because I know that one of the functions return a value. So
yeah, if the method returns a value, you have to say what the return type is.
I did public static boolean the name and parameters. Is that okay?
It might be okay depending on what the method is supposed to return. If the method returns a Boolean value, then it has to say it returns a Boolean value. If it has to return an int value, it should return an int value.
Thank you.
Okay. What else was I going to say?
How much does quiz 1 cover?
Quiz 1, how much does quiz 1 cover? So that's not an appropriate question at this point in time. The quiz is not for 3 weeks yet. So quiz 1 is going to cover roughly the first 8 or 9 lectures, roughly. Sorry?
Never mind.
Anything else? All right, so I think we'll just pick up where we left off in the last lecture. So we were talking about strings. Now the thing to remember about strings in Java, one of the important things is that they're immutable. So you make a string, you can't change the characters. Compared to Python, one of the other differences is that, well, there's several differences compared to Python, right? So in Java, the elements of a string, they're all of type char somewhere. Right? So the elements of your string, they have this type little c char. right, which is different than Python, right? And so in Python, the elements of your string are themselves strings. You can't use square brackets with a string, right? So to access the element of a string, you need to use the method char at. Where'd that go? Have we got to there yet? Sorry. Oh, here it is. Okay, so we're going to talk about that in a second. Sorry, we haven't gotten there yet. Right. The string class itself has both static and non-static methods. Right. So to uppercase is a non-static method. When you call the non-static method, you need a string object to call the method. Right. There are static methods in string. So the static methods in string, you use the name of the class to call the method. Right. And so there's an example of using value of to take a double value in this case, right, and get the string representation of that double value. All right, so this was the last slide from the previous lecture. If you want to test if two strings are equal, right, in Python you would just use equals equals or not equals, right? In Java that's not the case. So the problem in Java is that if you write equals equals, right, it often gives you the correct answer. In this particular example, it gives you the incorrect answer. Right? And so string equality means that the two strings have the same length, they have the same sequence of characters. So here I've got the string hello. Right? Now this is we haven't seen this yet in the course. Right? The next line also makes a string object hello. So new string hello makes a string object whose value is also hello. Right? And so this is an example of using the new operator in conjunction with what's called a constructor. Right? So this line here, that's the normal way that you would make an object in Java. Right? So on the assignment, if you've done the assignment, right, when you make a random number generator object, right, you write new and then random. Right? The name of the constructor is the same as the name of the class. Right? So string has constructors as well as methods. Right? So if you want to make a new string that has a sequence of characters HELLO, you could write it this way, but no one does. So that's the funny thing about the string class. Right? The string class lets you do stuff like this. Right? And that's the way that most programmers would create a new string if they knew what characters they wanted in the string. Right? They would not use the constructor here. Now if you want to test if two strings are equal, right, you should use what's called the equals method. Right? So you write some string object here, right? Dot equals, and then in the brackets, some other string object there. You can put whatever you want in here, actually. It doesn't have to be another string object. It could be, I don't know, like a random number object, right? And that will return false in that particular case. Right? So equals tests if the two strings have the same length and the same sequence of characters. So in this case, they're both hello, so that's going to return true. Now, with string, if you write equals equals, it often gives you the correct or the expected answer. Right? In this case, it returns false, so that's good, right? Because the string s is not equal to the string t, right? And the problem is this operator right here, that equals equals operator. So if you're comparing primitive values in Java, you want to use equals equals. There is no dot equals for primitive values, right? So for example, I'm just going to use this main method here as an example, right? If I have int x equals 1, right, and I have int y equals 2, right, and I want to test if they're equal, right, I can write x equals y, like that, right? If you try to write eq is x dot equals y, right, that doesn't work, right? So why doesn't that work? Well, equals is a method. It's a non-static method, sorry. When you call a non-static method, you need an object reference to call the method, right? Primitive types aren't objects, right? So x is not an object, right? It's a primitive value. And so that means there are no methods that are associated with the variable x, right? If you try to write x dot anything, the compiler will complain, right? X is not an object, or x does not refer to an object. You can't call a method using x, right? So don't use equals to compare two primitive types, right? Always use equals equals or not equals if you want to test if they're not equal, right? So x not equals y, right, is the not equals operator in Java. Okay, with strings, the situation changes. So string s, Hello? Oops, sorry. String T. So I'm going to write this a little bit differently. I'm going to write it like that. Right, so that's going to make the string T using concatenation. Right. I have to, let me comment out this line so this program will actually run. So EQ equals S equals T, like that. And then I'm going to print out the value of EQ. Right, so that works. And the program compiles, it gives you the expected answer. Right? So if you look at those two strings, you say, hey, yeah, those are both hello. Right? They should be equal. Right? And so the trap that new Java programmers fall into is that when they compare objects, they use equals equals. Right? So if you change this, right, so that I create the first string using a constructor instead and run the program, you now get false. Right? And now all sorts of confusion occurs. Right? You're saying, hey, S and T, they're the same string, right? Equals equals looks like the equality operator in Java, right? Why is this telling me false? Right? And the answer is because equals equals is the equality operator in Java, but it tests if the value of S is equal to the value of T, right? So for primitive types, the value of the variable is the value that's you've assigned to the variable, right? So the value of X is 1. The value of Y is 2, right? Now remember, what do reference variables store? They store references to an object, right? So in other words, they store something like a memory address of an object. Right? So S stores the memory address of that string object. Right? T stores the memory address of a different string object. Right? And so when you call equals equals using S and T, you get false, which is trying to tell you S and T refer to different objects. Right? And this is very strange because when you do the following, right? So if I get rid of the constructor call and just use a string literal instead, right? Now it seems to work, right? Now it says true, right? So given what I just told you, what's going on, right? Well, S and T both refer to the same string object, right? And that means something has happened here, right? That looks like a string object, right? That looks like a second distinct string object. Right? It happens to have the same sequence of characters, right? But it turns out in the Java language that's not true because of the way that the string class works. So the way that the string class works is that if it sees a string literal in the program, right? So it sees something inside double quotes, like that, right? It remembers it's seen that string before, right? So now inside the string class, it's keeping track, hey, there's a string literal, H-E-L-L-O. If the program sees another string literal, again with the sequence H-E-L-L-O, it will just reuse the existing string literal. It won't make a new one, right? And so here, the compiler is smart enough to know that if you take two string literals and stick them together, right, that's equal to the string literal H-E-L-L-O, right? And so it reuses the existing object that's already stored somewhere in the string class, right? And that's why you get true here. And this is why equality with strings especially is very confusing. Right? If you want to test if two strings are equal, always, always, always use dot equals. Like that. Right? That one always tests whether or not the two strings have the same length, right? And have the same sequence of characters. Right? So it doesn't matter whether or not I've used the constructor here. Right? You always get true, right? So so if you're comparing two references for equality, use dot equals. It's almost always the right thing to do, right? If you're comparing two primitive values, always use equals equals or not equals, right? Or exclamation mark equals, right? That's always the correct thing to do. Okay, so remember, you want to compare two strings for equality, use dot equals. So just like in, oh, sorry. I'm using the CMPE version of the slides. Everywhere it says big C, just assume it's big P Python. Sorry. So like in Python, right, a string is just a numbered sequence of characters, right? So every char in the sequence has an index, right? So you can imagine that this is you can sort of imagine that this is an array of char, right? So the big C at the front has index 0, right? The second, the I has index 1, and so on and so on and so forth, right? Just like in Python. The number of characters in the string is called its length, right? So in Python, to get the length of any sequence, you call a function len, right? There is no len function, or there are no functions whatsoever in Java, right? So you're never calling a function to get the length of a string. Here you're calling a method, right? So every string object knows how long it is. So to ask for the length of a string object, right, you use a variable, then dot, and then length, round bracket, right? So it's a method, so you always need the round brackets at the end. Right? So the length of sys124 is 7, right? 7 characters in sys124, right? There is an empty string in Java, right? So double quotes, no space in between, right, is the empty string literal, right? And the empty string has length 0. If you're writing a method that operates on the characters of a string, you have to account for the fact that there are empty strings in Java. Right? If you want a character somewhere in the string and you want to use an index to access that character, you use char at, right? You cannot use the square brackets. Furthermore, you cannot write a for each loop to iterate over the elements of a string. Right? If you need to iterate over the elements of a string, you have to use a counting style loop. Right? There's no way to use a for each loop. The reason for that is because strings were put into the language in the very first version of Java, right? The for each loop didn't show up until many versions later, right? And so they could not retrofit the string class to also support the for each loop. So here's my string, sys124, right? I want to print out each character of the string on a separate line, right? So you write a little loop that loops over the elements of the string, right? So starting at index 0, going up to but not including the length. Right? Each time through the loop, add 1 to my string to my loop counter. Right? In the loop, I'm just going to call char at and pass in the index I. Right? So 0, 1, 2, 3, 4, and so on. Right? And again, I'm just going to print out the individual character each time. Right? And that'll print out sys124 on 7. One character of sys124 over 7 lines. So there's a method that counts the number of times a specific character occurs in a string. Right? So FREQ is short for frequency. Right? You're going to pass in a string, or the caller will pass in a string. It'll pass in a character that they're searching for. Right? This will count the number of times that the target character appears in the string S. Right? So this is a simple counting problem. Right? You start the count at 0. You loop over the elements of the string. In each loop iteration, you get the ith character of the string, right? And you compare it to the target character. Right? Now remember, char is primitive. So if you want to test if two primitive values are equal, you use equals equals. Right? So is the ith character of S equal to the target character? If it is, add 1 to the count. Right? Count equals count plus 1, count plus equals 1, plus plus count. However you want to write it, they're all fine. Right? And then return the count after the loop is over. Right? And if you want to call the frequency method, well, this one happens to be static, right? So to call the method, right, you use the name of the class. Right? I put the frequency method in the strings with an S class, right? And so strings.freq, and then the name of the string, or sorry, the variable containing the string, and then the letter that you're searching for, right? Strings are case sensitive, so the big uppercase C is different than the lowercase c. So this should be sys124, sorry. This is a copy and paste error. I should fix that. I'm pretty sure that the lecture slides on the 124 website are correct. These are the ones from the CMP 212 course. What am I doing? I'm just screwing everything up. Sorry, hang on. Yeah, the slides online are correct, I think. Sorry, I should have double checked that I actually had the right set of slides open when I did this.
Why are the slides the same as
Whoa.
Why are the slides different?
There's two similar courses that I teach. Okay, so there we go. So CISC 124, how many times does the uppercase C appear? Well, twice. Right? The lowercase c appears 0 times. The 2, oh, I screwed that up too. Sorry. So the 2 appears once in CISC 124. All right, so usually when you're using strings, at least for courses like this, right, you're just going to rely on the methods that are inside the string class itself. Right? So if you actually go and look at the string documentation, you'll see that the string class has many, many, many methods in it. Right? We're not gonna. It's not. You don't have to know how they, how all of the methods, what all of the methods are. Right? You only need to know the ones I'm talking about during the lecture. So if you want to know, does a string contain another string, right? Not another character, right? You want to know does it contain another string, then you use the contains method. Right? So does CISC 124, does it contain the substring CISC? Right? The answer is yes, it does, right? It's at the very beginning. So that's true. Right? Does that course name contain all lowercase CISC? The answer is no. Right? Does it contain the string 1? The answer is yes. Right? Now, when people, when new programmers see contains, they think, oh, I want to look for a character, I'm just going to call contains. Right? And so they try to ask, does the string contain the character big C? Right? And this is when you get an error. Right? So the compiler flags this and it says there's no method called contains that takes in a char. Right? Contains takes in a string. Right? If you want to test if it's a char, if a char is in the string, right, you have to pass in a string. So if I want to test if the uppercase C is in the string, right, I can use string concatenation. So take the empty string, concatenate that with C, and that gives you the string big C. Right? And now you can test is the string big C part of the string? The answer will be yes. Right? If you want to test does the string contain a char, right, then the methods that you should use, or there's a few of them, right? There's several methods that look something like index of. Right? So for index of, that tells you what is the index of the first location of a specified character in a string. Right? So what is the index of big C in that string there? Right? Well, it's 0. Right? It's the first character in the string. Right? What's the index of the P? Well, that's 2. Right? The third character in the string. Right? What is the index of the 2? So there's 2 2s, so it gives you the index of the first 2. Right? So that's 4. Right? If you ask for a character that's not in the string, right, it returns -1. Right? So notice it's not returning a Boolean value, it's returning the index of the element. Right? So if you want to test does a string contain a specified character, right, you can call index of and test if the value is or is not -1. Right? So if it's not -1, you know it's in the string. Right? If it is -1, you know it's not in the string. If you want to search for the location of the last character, well, there's a last index of as well. Right? So what's the last index of the 2? Well, it's the index of the last 2, sorry. Well, it's the one at the end of the string, so that's index 6. Right? Otherwise, it behaves the same as index of. Equals is your method to test for string equality. Right? Always use equals. Right? If you want to test if 2 strings are equal. Right? Do not use equals to test if 2 strings are equal. Right? We've seen the plus operator already lots of times. So the plus operator is the string concatenation operator. Right? You can concatenate anything to a string in Java. Right? It can be primitive type. It can be of any reference type. It will always work. It may not give you the string you're looking for, but it will always work. Right? It will always do something. Right? So here's James Bond 007 in one string. Here's James Bond 007 made by joining 3 different strings. Right? Are they equal? Yes, they're equal. You can concatenate primitive values to a string. Right? So I can do James Bond and then +0, +0, +7. We've seen that already too. That works just fine. right? But always be aware, if you're doing this sort of thing, right? If you really want to make a string, then it's normally pretty important that you start with a string, right? So here, we've got the character H, the character A, and then concatenated with the string HA, right? You would think that produces ha-ha. It doesn't. It produces 201 ha, right? Why does it do that, right? So Java looks at that expression. It sees something plus something plus something, right? It looks at the precedence now of the operator, right? So the precedence of these two operators are the same, right? So if you have an expression where all the operators have the same precedence, Java goes left to right. So we have char plus char, right? From the previous lecture, you know that converts to int plus int, right? So whatever the int value of h is gets added to whatever the int value of a is. It turns out that's 201, right? Now you have an int concatenated with a string, so now it does string concatenation, right? And you get 201 ha, right? So if you want to do this the correct way, right, make sure that the first thing in the sequence is a string, right? The easiest way to solve this particular problem is to put the empty string here and then concatenate that with the h, right? And then everything will happen using string concatenation. Okay, substring. Substring.
What means the interval you can treat it as?
Pardon me?
You can treat it as an interval of which position to which position.
Substring?
Yeah.
Yeah, so substring gives you back a substring of a string, right? So it's like, it's similar to a slice in Python, right? So the substring method is more or less equivalent to the slice of a string in Python, right? So if my string is the 7 characters A, B, C, D, E, F, G, right? Then you can ask for the substring starting at a particular index going to the end of the string, right? So if you pass in 1 index, right, that's the starting index. So the substring starts at the 1, goes to the end of the string. So starts at B, goes to the end of the string, right? You get B, C, D, E, F, G. If you pass in 2 numbers, then it's similar to the Python slice, right? That's the starting index. That's the stopping index plus 1, right? So the slice or the substring does not include the element at that index, right? So for this particular example, it includes only the character at index 3, which is the D. 5, 7 includes the characters at index 5 and 6, right? So that's the F and the G, right? Otherwise, it works the same as Python slice. You can't use a negative index, right? If you want to compare 2 strings for dictionary order, which is actually called lexicographical order, right? But dictionary is easier to say and for most people easier to understand, right? Compare to is the method that you want to use. So if you ever see compare to in Java, that is the analog of less than, greater than, and equal to for references, right? So if you have 2 reference variables, you cannot use the less than, greater than operators. It doesn't work in Java, right? If you want to compare the objects for some kind of order, right, then it's always compare to. If you have primitive values, then less than and greater than and all those other operators work, right? For references, it's always compare to, right? So compare to for 2 strings returns a negative value, negative integer value, if the string S, or the string referred to by S, comes before the string referred to by T in the dictionary, right? It returns 0 if the 2 strings are equal, right? And it returns a positive integer value if the string referred to by S comes after the string referred to by T in the dictionary. Right, so for example, I'm going to compare aardvark and zebra, right? So S compared to T, well, aardvark comes before zebra in the dictionary, so you get a value that's less than 0, right? S compared to S, so that's aardvark compared to aardvark, that's 0, right, because they're equal. T compared to S, so zebra comes after aardvark, right, and so that gives you a value that's greater than 0. Now, if your strings are I have to make sure that I do this the right way. Okay. But let's do it this way. All right, now it can be the case that your 2 strings have or start with the same sequence of characters, but they're actually different, right? So here they both start with an A, right? Now, the compare to works by comparing their dictionary order, right? So it's still the case that the string AARDBARK would come before the string AEBRA, right? So it doesn't just compare the first character, right? It compares all of the characters until it realizes that the two strings are different, right? So aardvark still comes before AEBRA, right? AEBRA still comes after aardvark, so the values here are still correct, right? The actual value that's returned, if you want to know what the compare to returns for strings, you can go look at the documentation, and it will tell you exactly what this value corresponds to, right? But normally when you compare, when you're using compare to, you're only interested in whether or not the value is negative, 0, or positive. Right. If you want to replace characters or a substring in a string, that's the replace method. Now you have to remember that replace doesn't change the original string, right? It computes a new string by replacing the specified characters in the original string, right? So if you start with sparring with a purple porpoise and you replace all the P's, right, you get starring with a turtle tortoise, right? S is still the same, right? So S is still sparring with a purple porpoise, right? So T is the string that's formed by replacing all of the P's here with a T, right? Now you can also replace substrings in a string. So hi ho, it's off to work we go. I'm going to replace hi ho with oh no, right? And you get oh no, it's off to work we go. These two strings do not have to be the same length, right? So I could replace all the hi ho's with the empty string, right? And you would get comma, space, it's off to work we go, right? So these two strings don't have to be the same length, right? All occurrences get replaced, not just the first or the last. There are many other methods in the string class, right? So just like the Python strings, the standard library has a rich set of methods for you to use. It doesn't have every possible method that you might want to use with strings, but it has a lot of them, right? And so if you encounter a string problem and you're not sure how to solve it, the first thing you do, right, is you go and click on that link there and see if there's a method that does the work for you. All right, any questions about using strings in Java? All right, super. Next lecture. All right, so the next lecture is the floating point lecture.
What? Why?
All right, so this lecture tells you, or introduces you to how floating point numbers are actually represented on your computer, right? Remember with ints, right? When you do arithmetic with int, it's not exactly the same as arithmetic in math, right? You've got this phenomenon called overflow, right? Why does overflow occur? Because on the computer, you have a finite number of bits to represent an int, right? You can't represent every possible int, at least not in Java, right? And so you run into issues where there's some maximum value and there's some minimum value that you can represent, right? Floating point numbers run into a similar set of problems, right? But there's other very weird stuff that happens in floating point, right? If anything, floating point is even stranger than integer arithmetic. Right? So in Python, your floating point type is called float, right? Confusingly, in Java, the corresponding type is called double, right? So if you want a floating point number in Java, normally you use double, right? The type called float, right, is the smaller version of double. So if you know what bits are, float is always 32 bits, double is always 64 bits in Java, right? So they occupy a fixed and finite amount of memory. That means that just like with ints, right, you can't represent every possible floating point, every possible real number on your computer, right? And it's very strange because numbers that you think ought to be representable are not, right? So for example, if I take 0.1, and 0.1 and add them together, right? Mathematically, it's 0.3, right? If you ask Java, is that sum equal to 0.3? It will tell you no. It will say it's false, right? So you almost, you have to be very careful when you are doing comparisons with equality in floating point, right? It's almost never the right thing to do. So be very careful there, right? If you don't believe me, you can just run it in Eclipse, hopefully, Here. Okay. So here in this program here, right, there's my sum, right? There's where I test are they equal, and now I'm going to print out are they equal. Right? So run that, and prints out false. They are not equal, right? And that's very strange to most people, right, when you see this the first time, right? 0.1 looks like you ought to be able to represent 0.1 exactly, right? 0.3, it looks like you should be able to represent that exactly, right? So why on earth is the sum of 0.1, 0.1, 0.1 not equal to 0.3? Right. Oh, so it's not there. So I guess I'm talking about this program now. Okay, so this program here uses this class called Big Decimal. Big Decimal in Java is the class that you can use, you can use to represent an arbitrary number of digits in a floating point number. Right? So what I'm going to do is I'm going to take the number 0.1. Right? I'm going to pass it to the method called allDigits. Right? So up here is allDigits. Right? AllDigits takes the value that you pass in and makes a big decimal object out of that value. And so I don't remember the exact details, but I believe that the value that you get here, this gets converted into a 128-bit floating point number. Right? So much big, so it's twice the size of a double, or twice the amount of memory as a double. Right? And then I just print out the number. Right? And so when you run that program and you look at what 0.1 is, right, it looks like, as far as the computer is concerned, 0.1 is not exactly 0.1, right? It's 0.1, then a bunch of zeros, and then you get a 5, right? So 0.1 is not exactly 0.1. The sum, 0.1 plus 0.1, is not exactly 0.2. It's 0.2, a bunch of zeros, and then a 1, right? The sum, 0.1 plus 0.1 plus 0.1, is not exactly 0.3. It's 0.3 and a little bit, right? If you add 0.1 4 times, it's 0.4 and a little bit. Strangely enough, if you add it 5 times, you get exactly 0.5, right? So that seems to work, right? What is the value of 0.3? Doesn't even start with a 3. It starts with a 2. It's 0.29999999999, right? And so you can see from this program here, right, it should be obvious why the computer doesn't think the sum, 0.1 plus 0.1 plus 0.1, is not equal to 0.3, right? Because that's what it thinks 0.3 is, and that's what it thinks the sum is, right? They are not precisely equal. All right, so that little slide, that example there is somewhat deceiving, right? If you use a double value in Java, right, then that corresponds to roughly 15 to 17 significant digits if you're writing down a base 10 number, right? So if you're writing down something, point something in your computer, right, you've got roughly somewhere between 15 and 17 digits that you have access to, right? That program there prints out many more than 17 digits, right? There's a lot of digits in that output, right? So you have to be careful here. Those digits aren't actually, you can't actually represent numbers that look like that on your computer. So what's actually happening here is that when you take the double value, right, so 0.1, and you, when you write down 0.1 in base 10, right, the computer has to convert that to base 2, right? That conversion is where the problem occurs, right? So when you convert from one base to another base, it's often the case that you can't represent the number exactly, right? Right, so when it prints out the value, it takes the converted base 2 value and reconverts it back to base 10, right? And so that operation does not give you back the same value as before. And so what the program is printing out, it's printing out the conversion from base 2 back to base 10, right? And it's printing out all of the digits it can when it does the conversion, right? Those digits aren't actually, you can't actually use that many digits when you use a double, right? So just keep that in mind. All right, so what's going on here? Well, to figure out what's going on here, you need to know how are floating point numbers actually represented on the computer. They're represented using this standard here, so the IEEE 754 standard. This was, I forget exactly when this was finalized. It was sometime in the 70s or 80s when this standard was written and finalized. So this is the standard that most computers use. most modern computers use for floating point arithmetic. Before the standard was created, whoever created the CPU or whoever wrote the compiler would decide how they would work with floating point numbers. Right? So the standard is meant to standardize how floating point numbers actually work. Right? The standard is very long. Right? Many, many people contributed to it. Some of the people who contributed it have Turing Awards, which are the Nobel Prizes in computing science. Right? So this was no small task to make the standard. It's not your job to understand the entire standard. What you care about, though, is that all floating point numbers are represented like that on your computer. Right? So every floating point number is signed, so plus or minus. Right? There's some integer value called s, or the significand. Right? And you take that integer value, multiply it by 2, and raise it to some integer exponent e. Right? The 2 shouldn't surprise you, right? Because your computers are binary. They're all digital, right? So they use binary as their internal representation. That's where the 2 is coming from. Right? The fact that s and e are integers is just the way that the standard was designed. Right? The e can be negative. Right? All right, so why can't you represent 0.1 exactly? Right? So why is 0.1 not 0.1? Why is it 0.1, 0, 0, 0, 0, 0, blah, 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 blah? Right? So the answer is because you cannot write 0.1 like that if s and e are integer values. Right? And you can easily prove this by contradiction. Right? So let's assume that I can find some integer s and some integer e such that this expression is true. Right? So if you look at that for a second, you might think that can't possibly be true. Right? I'm multiplying something by 2, and the value over here is less than 1, so that doesn't make sense. Well, e can be negative, right? So if e is negative, it's 1 over 2 to some exponent, right? And that lets you get values that are less than 1, right? So in this case, e is going to be negative. All right, so all you do is the following, right? I'm going to multiply both sides by 10, right? That lets me get rid of the decimal point, right? So I now got 10s times 2 to the e equals 1. I'm just going to separate the s and the e onto opposite sides of the equation. Right? So take the 2e and divide both sides by 2e. Right? Now remember, 1 over 2 to the e is just 2 to the minus e. Right? We know that e is negative. So the right-hand side is basically 2 times 2 times 2 negative e times, right? Or the absolute value of e times. Right? So there's the absolute value of e2s on the right-hand side. Right? What's the left-hand side? Well, 10 is 2 times 5. Right? I don't know what s is, but I don't care what it is either. All that I care about is that there's a 5 here. Right? So on the right-hand side, the prime factorization is all 2s. Right? I've got something that's all 2s. On the left-hand side, the prime factorization includes at least one 5. Right? Therefore, there is no way that I can find an integer value s such that this equation is true, right? There's no way to make the prime factorizations of both sides equal. So you can't even represent something like 0.1 exactly on your computer, right? It's 0.1, a bunch of zeros, and then something else, right? Notice that, it's very close to 0.1, right? There's many, 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 many zeros here, right? Before you run into a digit that's not 0, but it's not exactly 0.1. All right, so float and double, they are 32-bit and 64-bit binary values, right? I don't want to write out 32 digits or 64 digits on the slides, right? Furthermore, I don't want to work in binary, right? I don't want to write in all zeros and ones, right? Because I don't understand what I can't really interpret them easily, right? So for all of the examples in the rest of this lecture deck, I'm going to use base 10, right? And I'm only going to use a small number of digits. Right? So all of our floating point numbers are only going to have 4 digits, right?
Why 4?
Why not?
Right. More.
Okay, so all of our floating point numbers, they're going to have the same representation, right? There's going to be an integer here times 10 because we're working in base 10, raised to some exponent up here, right? I get 4 digits to write the number, right? So 1, 2, 3, right? One of the rules I'm going to use to keep things simple is that D1 is never 0, right? So the smallest value of D1 is 1, right? Which means the smallest significand you can have is 100, right? Now for the exponent, I'm going to use one digit, but I need to be able to get negative exponents, right? So I'm going to subtract 5 from that digit to get the exponent, right? So that lets me have exponents in the range from -5 to 4, right? And so all the examples going forward, they're going to look like this, right? Let me do one more slide, and then we'll call it quits for today, right? So if you start to scribble out what these numbers look like, right, you get the following table, right? So we can start out by saying, what's the smallest positive value that I can write? Well, I need 3 digits in the significand. The first digit can't be 0, right? So that has to be 100, right? What's the smallest exponent that I have? Well, that's -5, right? What is that in decimal? That's 0.001, right? Now you ask the question, what's the next largest value that you can represent? Well, that's 101 times 10 to the -5, right? Which is 0.000101. What's the difference between these two values, right? 0.0001, it's the exponent over here, right? It's 10 to the -5. Now you keep on going, right? You get to 9999 times 10 to the -5, right? Your next number is 100 times 10 to the -4, right? Your next number after that is 101 times 10 to the -4. What's the difference between these two values? It's 0.0001, which is different than that value there. Right? So not only do you have a finite number of values that you can represent, the spacing between adjacent values is different. Right? Here the spacing between these two numbers was 10 to the -5. Now it's 10 to the -4. When you get up to the upper end of the range, the spacing between values is now 10,000. Right? I can't represent any number exactly between 1 million and 1,010,000. Right? Anything in between those two values gets converted to that or that, right? So this is one of the implications of using a finite number of digits, right? And this particular representation, right? You've only got a finite number of double values that you can represent exactly, right? Furthermore, the spacing between adjacent double values changes, all right? So I will let you digest that fact, and we'll come back to this in the next lecture.